Good day, everybody. I'm Mr. Le Cordeur, and I'm back. Today we are here at Notable High School, the historic town of Paul. Beautiful town, not as beautiful as Wellington, though, but that is a topic for another day. Today we're talking about number sequences or number patterns, and we're going to just recap on the few basic number patterns that we have, and we're going to ask this grade 11 class that's sitting right in front of me to share their knowledge up until this point. So grade 11, the question now is to you, what kind of number patterns have we already looked at? Yes, there's a hand. Lisa Kanye says quadratic, all right? Quadratic pattern, all right? And arithmetic pattern, okay? And then geometric pattern, okay. Seems like that is now your most common patterns. We have other patterns, but we don't formally look at them. So that kind of patterns we will more like solve intuitively. Yeah? So we look at the patterns, we'll see, for example, like I'm just going to make an example, say for example, yeah, it's difficult thinking on your feet of a pattern. All right, let's use 3, and then the next number will be 5, and then the next number will be 6, and then the next number will probably be 6, and then the next number will be 9, and then the next number, sure, will probably be 7, and then the next number will be 3, 5, 6, 7, 6. Is it 10? All right, 5, 6, 7, 3, 6, 9, and then 12. Did you see there what happened? So this is an example of a combination pattern. So what we have 3, 5, 6, 6, 9, 7, 12. Now, with regards to consecutive terms, if you look at it like this, term 1, term 2, term 3, term 4, term 5, and term 6, there's no clear quadratic, arithmetic, or geometric pattern that we can recognize there. However, yes? But isn't 9 what? Term 5, yeah. So 1, 2, 3, 4, 5. All right, so this one is term 5, and then this one is term 6, and this one is term 7. All right, but getting back to what I'm trying to say is that there's no clear geometric or arithmetic pattern that we can recognize there. All right, nor is there even a second difference. But if we go now and we see, okay, but there's actually a relation between every other term. So skipping a term, what is the difference there? Plus 3. And then skipping a term, I have there plus 3. And then here, I have plus 3 again. And then here, with these two terms, I'm plus 1. All right, so check out for that because they'd like to do that. This is an example of a combination term, a combination pattern. So I'm just showing you, you should be able to identify this. It's not formally taught in class, but you should also be aware that they can combine and stuff like that. So getting back to the most formal ones, and there's a few characteristics that we can identify here. You can tell me what is the characteristics of a arithmetic pattern. It has a first constant difference. All right, so we normally refer to that. It has a first constant difference of D. No? What else do you know about this? What is how do we determine the general term, for example, of this one? Tn equals to A. Now what is A? First term plus D. All right, so that is how we determine. And then how do we determine the D? You spoke about D and you said D is a constant difference, but how do we determine D? All right, so C says the second term minus the first term. But is it only that? No. So what can we say in essence is actually the difference between the consecutive terms. So that means, for example, if I write it formula and not in terms of number, it will be Tn minus Tn minus 1. So if this is, for example, 100, that will be 99. No? And that is how we determine the difference of first constant difference. Then we have a geometric pattern. What do we know about the geometric pattern? It has a, think about that quickly. Raise your hand. Yes, Kazimla, your hand is up. We have a ratio. Yes, we're talking about a constant ratio, and the ratio gets defined with R. All right? So how do we determine R? Just like we determine D here, which is a constant difference, we can also determine R. And R, we can say, Edwell, is, we divide the consecutive terms. So it's actually the quotient of the two terms. No? So for example, let's use term 5 will be divided by term 4. So it is, in essence, if we want to use any number, it's going to be the term number divided by term number minus 1. And I'm using this reference because sometimes when you go further, you will see they're using n and other letters, but you shouldn't get confused. It actually just means more, they can use, we're using numbers, and numbers is just helping us to understand it. All right. And then here, algebra is also painting a picture for us there. Then our quadratic pattern is characterized by, all right, have you done anything? So I have the formula. How do we determine the general one for this? Tn is equals to A times R multiplied with n minus 1. All right, where A is the first term, R is the ratio, and you just substitute and then you get there. From that, you can determine any term or any question basically there. All right, now looking at the next one, we have the quadratic pattern. The quadratic pattern is characterized by, all right, I'm going to leave that comment with you guys. What she says is absolutely correct. I haven't dived into that. So the first difference is actually, it forms a linear pattern. No? And that linear pattern brings us by a second constant difference. So we can say that a quadratic pattern is characterized by a second constant or common difference. All right, second constant difference. Then there is, it is quadratic in nature. No, like this is arithmetic pattern is actually linear in nature. So that means if we were to graph all of this, if I was to graph an arithmetic pattern, it can go something like a straight line, but it can also go, that is a positive increasing, but we can also have a negative straight line, no? Or a decreasing one. Then if we go now graph, so this is now the algebraic part. This is your graphical, or your, almost you can say it's like your functions of that. Then we have the, this is a arithmetic pattern. A geometric pattern is in nature, or it is of exponential in nature. All right, so if you can remember maybe, or thinking about, I'm moving towards functions now. Now, do you see the correlation? And I'm trying to see that all of these stuff is somehow interlinked. And I want you to make that connection, because if you make that connection, it's actually going to be a lot easier. So this geometric pattern can be, sometimes it increases exponentially, but it can also be decreasing exponentially as well. No? So, and we will later, when we do functions more formally, we will see, and I want you to remind me, sir, that we need to come back. What is the correlation between these two stuff? No? And then this one, a quadratic pattern. So in functions, we have the linear function, we have the exponential function, we also have the hyperbole. But what else do we have? A parabola. No? And a parabola looks something like this. In grade 10, you did parabolas, that looks like this. It normally turned on the x-axis, but in grade 11, it's not going to turn only on the x-axis. It's going to shift. So you can turn there. This is the one that has the a value is positive, no? And then we have one where your a value is negative. So there's your parabola which has a positive and a negative one. All right. So what I'm going to do, I did already, but I'm just going to look at another example of the quadratic pattern, and then we're going to work through a few more stuff there. Where is this? Good. Let me see this example. All right, let's take a look at the example. You don't have to write this down. You can just slow down the video. If I'm going too fast for you, you can put it in slow-mo. Then I will talk something like this if you put it on the slow motion effect on 0.8. What I do for myself, I watch videos at almost 2 times the speed. So that means in essence, I'm learning twice as fast. So in a span of 20 minutes, if the video is 20 minutes, I halve that, it's 10 minutes. Then I can watch 2 of that videos, and that's how I actually learn. But and your brain is, if you teach your brain, or if you get your brain actually adapts quite fast. But you shouldn't start with the 2 times speed. You should start with 1.5. You will see on YouTube there's options for you to do that. No, so that's actually a great way of how you can match this interplay there. And I feel sometimes like I've created a time machine because I'm moving in time faster than normal people. All right, to get back, we're looking at an example of let's just do, what is this example? 2, 5, 10, 2, 5, 10, 17. All right. I'm making up questions here. I hope the questions that I'm making up will be similar to, not exactly the same, but similar to questions that you can expect. The first question would probably be, write down the next 2 terms. Can you help me with that question? So we have here 2, 5, 10, 17. What is the next? So we need to know what is the next term. Anyone? Can I get a hand? 26. Now, how did you get to that? Can you explain to the viewers there at home? Because everyone isn't as smart as we are at this school. Why did we add 9? But here we added 3. Then we added 5. Then we added 7. Oh, okay. I see what's happening. So what is the term after this going to be? Then I'm going to add 11. 37. All right, do you see now? And this is now what Shulma pointed out to us. This is actually forming a quadratic pattern from there. All right, and we looked at this. Now we can say, okay, but this is not constant. And when we're talking about the first 2, geometric and arithmetic, we're looking for normally a constant, either constant ratio or constant difference. But there is not constant, but we can use this and go further from that, and we can say, okay, but this thing is actually constant from here. What is the constant difference there? 2. All right. Now this is the easiest way. There are other ways. No, we're going to look at that on another time. You can check out my other videos perhaps. I think the great thing is I watched videos that I created for grade 9s when I started here. And that I started here almost 300 years ago. It feels like an eternity. All right. But you can go check that videos, and that videos that I created for grade 9 when I started at this school. The grade 12s can actually use that videos for the current work that they are doing with Euclidean geometry. Because the work you will see is repeating itself. We're just moving up on another level. And when I was creating that videos for the grade 9 learners, I didn't realize, but this work is actually on a grade 12. It can also be used to revisit the grade 12 basics, or what you need for grade 12. So the reason why I'm doing this is for your purposes, Dristan, no? So that you can go and revisit before you write and improve your marks, because like I pointed out to you, I can remember since I got out of the womb, I was like, how's things going here and stuff like that. But I see we tend to forget quite often. No? So please work on your attention span. Now, who can help me? How can I determine now? Because say, for example, I want to determine term number 100. The next question will probably be term number 100. Okay, that's going to be too big. Let's make it term number 20. Term number 20. Should I continue with this pattern? I can, but it's going to be time consumption. It's going to take too long. So I want to get a quicker way, a more efficient way to get to an answer. So therefore we can say now term number 20, but in order to I first need to determine a general term. Now for the quadratic pattern, there's an easier way. We use basically a Tn is equals to an squared plus bn plus c. Then we just need to determine the value of a, b, and c. Now a, b, and c we've been taught since primary. It is the basics, no? It's the basics actually of life. What is the basic principle of life? Always be cool. A, B, C. Is that true? Yes. No. Stay calm and always be cool. All right. So for this one, to determine A. Now A, please take note. In this two, A was the first term. Yeah, it is, however, a little bit different. No? He's almost like the odd one out, but if we still allow him here because we accept people for who they are. No? So we're going to say that the first term, determining A, we're going to say 2A is equals to 2. Why 2? But what is 2 actually? D2. No? So when you write it down, and this is actually the general how you can work it out. So then you say 2A is equals to 2. Alright? And then you divide on both sides by 2, so A is equals to 1. How do we determine B? 3A plus B is equals to D1. No? And that's the first one there. So now we can say that is going to be 3. I take that 1. Because if I have a value for A, put it there, plus B is equals to 3. 3 times 3 is equals to 3. Sorry, 3 times 1 is 3. 3 times 3 is actually equal to 9. No? So that answer is 3 plus B. So that means that goes over, and that is equals to 0. B is equals to 0. Highlight this for you. No? And then you have the A plus B plus C. A plus B plus C is equals to that 2 there. Alright, so then we have here 1 plus 0 plus C is equals to 2. So that 1 plus 0 is equals to 1. We take, so C is going to be 2 minus 1, which equals to 1. Alright, so that means, did they ask me? They never asked me to determine ABC. Now I need to go back, and I told you, when you read, critical thinking, no? You pointed out to us, critical thinking. Critical thinkers, they say, critical thinkers are people who are supposed to be leading us. You can't have a person that just accepts everything that is your leader. You should have a person that is a critical thinker as your leader. So, and they say further, with that statement, they say that leaders are readers. So if you choose a leader, you should choose someone who reads as well. You should know everything. Now, why is this important? Because the question wasn't to answer ABC, but that's in essence what I've done. But now I need to go back and I need to answer the question. What was the question actually? The question was also not to determine the general term. The question was to determine term number 20. But all of those stuff is useful to us. No? So to determine term number 20 here, we're going to say, we first write down the general term. That's going to be Tn is equals to the value of A is 1. I don't have to write down that 1 because it's a coefficient there. No, but you should know it is there. Then plus B is 0. 0 times N is 0. And then plus 1. And a great thing to do. No? I'm talking to my friends there at home. Bushman, listen here. Bushman is my nephew. No? I'm speaking to him. So he's struggling with his maths last term. He got his report, and I'd ask him, how do you sleep? Because they only got 1/7. I'm like, how do you sleep? You're supposed to get straight 7s. Huh? Ik vraag me, hoe slaapt ze? He says he sleeps with his head on his pillow. Alright, just to get back. Bushman, I'm talking to you now. Listen to this, no? Follow this. Don't tell them who you are, but leave a comment there down below. So now we just substitute 20 there, so that gets me to 20 square plus 1, that's 401. 401. Alright. Do you see? Critical thinking. Sometimes you can do the maths. Sometimes we are lazy to do the maths. So there's a lot of stuff happening in your mind simultaneously. You see, I was explaining here, I was thinking about my nephew. I seen this out. I know there's a lot of stuff, but you need to channel your energy to what is important sometimes. All right. So that is that example. Why did it move on to the next one? All right. Let's just see what's going on here. So there's a lineaire rye. I know it is in Afrikaans, but we are also working on our Afrikaans. No? We're making this learners be proficient in both languages. Alright, so hulle sê van vorige werk weet ons dat 'n lineêre getalry 'n ry van getalle is waar daar 'n konstante verskil is. Constant difference, yes. Can you translate? Thank you, Lorna. Lorna's going to translate for us. Great stuff. All right, listen here, guys. I'm just going to pause the video.